Hi, fifth period. Pull out your new page of notes, write your name on the front of it. You'll be getting the rest of the packet throughout the unit, more of it tomorrow. And turn to the back and do a few of these problems with me. We'll learn more about the vocabulary of polynomials on Friday, but right now, I just want you to be able to operate with them, which is mostly add, subtract, and multiply. When you add polynomials, you focus on like terms. This is called the vertical method. If you like it stacked like that, you're welcome to rewrite some of the problems and do them this way. You only add coefficients that are in front of the term, which this would make it 4, and you leave the exponent as just a label. You had 3x cubes, you're adding 1x cubed, so now you have 4x cubed. Add the next column of like terms. Be careful of your signs. A positive 2 and a negative 10 would make a negative 8, x squared. And then the last term is isolated, no like terms, and it goes on the end. Standard form is when you write it so that your highest exponent is first, then your next lowest exponent, and then your last lowest exponent. And if there were any constant numbers, they go at the end. This is the goal of adding polynomials. Removing parentheses, distributing negatives, and just adding like terms are your jobs. So in the next one, if it helps you to color code like I am, you can look for like terms. You can see that 9y cubed has no like terms, so leave it alone. 3y squared with negative 5y squared is negative 2y squared. Negative 2y plus y is negative y. And a 1 plus a negative 4 would be a negative 3. When you distribute a negative, rewrite the back polynomial with its new signs before you begin. So this would be 2z squared plus 3z minus 3z squared minus z plus 4. Then add your like terms. You can also use these things if you like to show you're hooking them together. You get a negative z squared, a plus 2z, and a plus 4. Now let's move on to multiplying polynomials. You have certainly been doing a lot of things like this middle problem. Make sure when you see an exponent, you actually write your polynomial that many times and FOIL it or distribute as needed. So I want to do this one with you first just because you're so used to it. Just want to like reiterate, don't ever just distribute your exponent because you will lose these middle terms that give you negative 18y and another negative 18y that belong in the simplified answer. Your first times first would be an 81y squared, so we are adding exponents whenever we are multiplying two terms together. And then your 2 times your 2 and making it positive would be positive 4. Last, make sure you combine any like terms, so the final result here would be 81y squared minus 36y plus 4. Going back to the first one now, you just need to act like you're foiling, but there's an extra term. So y has to get multiplied by all three terms of the other polynomial, and then 5 has to get multiplied by all three terms. And you will end up with a really long list of terms. There should be 6 of them, but then a few of them will combine at the end. So starting with 3y squared times y would give you 3y cubed. We have to increase that exponent because y to the first and a y squared multiplied together makes us add our exponents. Then for the next set, we get negative 2y squared, and then y times 2, we just get plus 2y. Now kind of color coding in green, I'm taking the 5 times all three terms, so we get plus 15y squared. No reason to increase exponents there. Minus 10y plus 10. Now go look for some like terms. Nothing goes with your 3y cubed, so leave it out front alone. You have a negative 2y squared plus 15y squared, so we should have plus 13y squared. We have 2y with negative 10y, so minus 8y. And then last, your constant number of 10, so plus 10. This is not harder than foiling a binomial times a binomial. You just have more to keep track of. And so showing your work and keeping organized will be the key to not making any small mistakes. Now let's kind of jump down the page and look at how the multiplication problems can look otherwise. The one below the one that we just did is even easier. You just need to multiply negative 4p times all three parts, being careful of that negative and making sure you're adding your exponents. So the first set would be negative 20p to the fifth. Remember, you're multiplying your front coefficients of terms, but you are adding your exponents. So your brain has to think of two things at once. Okay, next, take your negative 4p cubed times your positive 4p, and that would leave you with negative 16p to the fourth. Think of this as a little invisible one if you need it. And then take negative 4p cubed times negative 8 and get positive 32p cubed. When it comes to a problem like this middle one or this one down below, you have to multiply two of them to start and then take that result times the last binomial. So let's do this one in the middle. So I'm going to focus on just foiling together the first two binomials. We would get x squared. On the inners, we get minus x. The outers, we get plus 4x. And last times last, we get negative 4. Do simplify this by combining those like terms. X squared plus 3x minus 4 would be your new trinomial in place of those two binomials. But put it back in parentheses and multiply it by your x plus 5 now. So don't reuse either of those binomials that you had up above. This time you want to take every term in the front polynomial times every term in the back polynomial. So to color code this, I'm going to take x squared times x to get x cubed, x squared times 5 to get 5x squared. Next, let's take 3x times x and 3x times 5. Oops, I almost made a mistake. And I'm not even there for you to correct me, but that should have been a squared. And then let's do negative 4 times x and negative 4 times 5. It won't always work out this nice, but you can see that your like terms kind of ended up side by side this time. And so it's already kind of in what we call descending order and should be easy to combine your like terms. Leave x cubed in front. Now you'll have plus 8x squared plus 11x minus 20. Okay, the last two that aren't like the rest are this one and this one. But hopefully what you remember from these types of problems is that you just are forced to write it down that many times before you start multiplying. So let's head down to this one. 4x minus 3 cubed is how you say that. But you have to write 4x minus 3 three times to show that's what you understand the exponent means. Multiply something by itself 3 times. So again, start with these two and FOIL them. We would get 16x squared minus 12x, and minus 12x are coming from the outers and the inners, and last times last would be a plus 9. Those don't cancel. Instead, keep it negative and add them together and get 16x squared minus 24x plus 9. And then we want to take it times 4x minus 3. And so now again, we want to take 16x squared times both of those to get 48x cubed. Wait, whoops, that's not 48, that's 64. 64x cubed. You can use a calculator on multiplication facts if you want. Then 16x squared times negative 3 is negative 48x squared. Okay, now let's take the negative 24 times both of those back numbers in the back binomial. Negative 24 times 4 is negative 96, and we would get x squared, and then plus 72x. And then let's take 9 times both of those to get 36x, and then minus 18. Hopefully I didn't make any mistakes because I can't go back and redo this video. Combine some like terms. They're side by side again, but they're a little bit bigger. Your answer should look something like 64x cubed minus 140, what? 44. I was going to say that before I calculated it. And 72 plus 36 added together is 108, but that'll be our x term, we call it. No exponents needed. And then minus 18. That should be enough to get you started on your worksheet that I left for you. We might do a couple more of these problems that I skipped as a warm up later, and let's do some of that vocabulary and sort of steps. These shortcuts can come in handy later. We'll talk about those on Friday and next week. Have a good day.